Now we're going on to using the completed square form. So now we know how to complete the square. It's how do we use this? And this is tying into our functions. So here I have a function, y equals f of x, but it's also 2x minus 1 squared minus 5. Okay, and we can relate this to our original parabola that we should all know from National 5 still, which is y equals x squared. And the function y equals x squared, we know, has a point on it, 0, 0. And that is the minimum turning point. It's that point on the graph. So we know we can now take that 0, 0, and we know that minus 2 here means we have to move our graph to the right. So we've got to move it to the right 2, so that then becomes 2, 0. And then we know that this one here means that our graph is moved down 5, so we've got 2 minus 5. And then we can now sketch the graph that has changed. And what has happened is it's gone along 2, down 5, and our graph has now been transformed into another one. So we know that our turning point has got to be there, 2 minus 5. But the other thing we need to know for this graph is going to be where it crosses the y-axis. And it crosses the y-axis when x equals 0. So when x equals 0, it crosses the y-axis. So we're going to get y is equal to 2 times 0 minus 2 squared minus 5. So we get 2 times minus 2 squared minus 5. And we get, so that's 2 times 4, which is 8, take away 5, which is 3. So we know we also have the point 0, 3. So we've got some point kind of up here somewhere. And then we can draw our parabola really quickly and really easily, as long as we mark that that is 3. And we're good. So we can sketch parabolas. Again, this is something that's been done in National 5, so just going over it really quickly. But also this means that from any completed square form, whether it's from the graph or from the equation, you can instantly tell you what the turning point of that graph is. So if we've got just any, so I'm going to write it in its general form. So we've got y equals p bracket x minus a squared minus b. We know that the turning point is always, you've got to do if this is a minus, it becomes plus, so you've got to change the sign, and then it's going to be whatever b is. So as you can see here, in our bracket, we've got a minus 2, so our turning point becomes 2, and the minus 5 becomes 5, and that's the same for any graph we've got. So far, all the versions we've seen in National 5 have been where p has been 1. So we're going to do an example of how this can change and how we're going to find that value of p from the graph. Right, so we've got a graph here, and we want to find the equation of this graph. So we want to put this into the form y equals p of x minus a squared minus b. Okay, so we want it to look like that. So our first place to start is to look at our turning point. So our turning point is going to give us our a and our b. So our x coordinate of our turning point and our y coordinate of our turning point, so we've got minus 2 and we've got 7. Our y coordinate just gives us our b value automatically. So in here we have y equals p bracket x minus a squared minus b. So we know that we're going to have y is equal to p, and then we've got x, we've got something squared, and then we're going to have to add 7 because the graph's been moved up 7 to there. And then in here, to find our value that goes for our a, it's the negative of this. So we've got to change the sign of our x value. So it's plus 2. Okay? And then we've been given our other point, which is 0, 5, and that's what helps us to find what this p-value is going to be. Because we can substitute that in to this equation we've got so far, this one, and that'll give us one variable. So one thing we don't know, if we substitute in our value for x and the value for y, we only have one unknown in our equation, and we can find out what that unknown is going to be. So if we substitute in 0, 5, we're going to get that 5 is equal to p times 0 plus 2 squared plus 7. So we get 5 is equal to 4p plus 7. So we're going to get 4p is equal to minus 2, and p is equal to minus a half. Okay, so if we think about that, does that make sense? This graph here, it is upside down, so it's the opposite direction from the one we had before. So that means that our x squared is going to have to be negative. Okay, that's another thing from National 5. I'll just do a wee reminder on the next slide about whether we know if it's going to be which direction, whether it's going to be a smiley face or a frowny face. Okay, but that means that we know that the equation of this graph is y equals minus a half x plus 2 squared plus 7. Okay, I'll do one more example for you. Before I do another example, it was just a wee reminder. If your graph is this way, then you have a minimum turning point and your x squared, and you've got a positive x squared. If your graph is this way up, you've got a maximum turning point and a negative x squared value. So this, for example, could be negative x squared minus 4x plus 5. It's not going to be, but that's a complete, just picked off the top of my head example. That one could be x squared plus 4x plus 9. Okay? Those are just complete, those are not what those graphs would look like, but they're examples. Okay? Right, so we'll do an example of sketching, like finding the equation of a graph. So if we've got one that looks like this, we've got our x, we have our y, and we have a graph that crosses at 0, 3, and then our turning point is at 1, minus 5. Okay, so now we can go into our equation. We've got to put it into the form y equals p x plus a minus b. Okay, whether you've got pluses or minuses in there, it doesn't matter. It's still just the standard form. So our turning point again tells us, our 1 minus 5 tells us this is just our b value, and that's the negative of our a value. So we're going to have y equals p, and then x, and it's going to be minus 1, and then it's going to be minus 5, and don't forget the squareds, like I did. Okay, and then we substitute in our value of 0, 3. So we're going to get 3 is equal to p times 0 minus 1 squared minus 5, which gives us 3 is equal to p, because minus 1 squared is 1, so it's just 1p minus 5. So then we're going to get that p is equal to 8. So we can substitute that in. So therefore, y is equal to 8 x minus 1 squared minus 5. Okay, the last thing that we need to be able to do with our completed the square form is to tell whether or not it's a maximum or a minimum directly from the equation. And that is using the information we've kind of got up here. So if we've got the positive x squared, we know that it's a minimum turning point. If we've got a negative x squared, we know it's a maximum turning point. And then we can find the coordinate of that turning point, because from the completed the square form, we can just read out the coordinate straight away. We change the value from positive to negative or from negative to positive of the value inside our bracket, and that gives us our x coordinate. And whatever we have out at the end gives us the y coordinate of our turning point. Okay, so we're moving on. Next, we're looking at sketching exponential functions.